Today we are doing trigonometric grade 10. Okay, but before we start, we need to understand what we mean when we talk about trigonometry, right? I'm gonna first start explaining what trigonometry is. Okay, by now you should know what trigonometry is, or there should be some stuff that comes at your head that you need to be thinking about when you hear the name trigonometry. Now, trigonometry is the field of study of mathematics which focuses on the relationship between the sides and the angle of a triangle. But because now we are at grade 10 level, we'll be focusing on the right angle triangles. We're gonna talk more about what a right angle triangle is. But now, how is trigonometry gonna add value in our lives? Okay, let's quickly look at. I have few options. Application of trigonometry. Trigonometry, it is used in many different fields. I just listed few of them so that you get to see where we are going with this trigonometry, because everything that we are doing in maths, at some point it has its own application. Okay, the first thing that I want you guys to realize, trigonometry, it is used in fields like astronomy, right? Now, astronomers need to calculate distance from one planet to another. They need to calculate from one distance from one star to another, the angle between those stars and planets, and all of that, it is powered by trigonometry. Okay, in geography, we are calculating angles, we are calculating distance from one point to another landmark. Okay, all of that, it is powered by trigonometry. The GPS that we use in our everyday life, it is powered by trigonometry. That app, it is built directly from a trigonometry system. Constructors and engineers, when they have to plan buildings, they use trigonometry in connection with EGD. Okay, but we're gonna talk more about that. But now, let us refresh our brain a little bit in terms of trigonometry. In previous grades, we know, because we've studied, what a right angle triangle is. But now we're just gonna refresh our memory a little bit so that we know exactly what we expect in this lesson. Okay, the first thing that I want you to pay attention into. Okay, if we have a triangle like this, right, and you automatically know that this is a right angle triangle. The reason for that, one of the angle, it must be equals to 90 degrees. It must be equals to 90 degrees. Now, how do we see that one of the angles is 90 degrees? We see that by this block, this square block at B, which indicates to us that this is a right angle triangle, because we have angle B, which is equals to 90 degrees. Okay, the second thing that I want us to pay attention, by now we know that the sum of all angles in a triangle, they must equate to 180 degrees. They must equate to 180 degrees. Okay, what does that mean now in terms of a right angle triangle? That simply means that when you add this angle A plus that angle C plus that angle B, they should give you 180. But by now we know that that angle there is 90. What does that simply mean? It simply means that angle A plus angle C, they should give you what? 90 degrees. So that when you take that 90 degrees and add it to that 90 degrees at angle B, then you have your 180. Okay, let's move on a little bit. Now, in terms of the right angle triangle, now the theorem of Pythagoras, it is applicable as well. Now, you'll remember, because we've done this at grade 9 level. Now, what does the theorem of Pythagoras state? It states that if we have a right angle triangle, now the hypotenuse, which is the longest side that we're going to talk about in few minutes now, in few seconds now, which in this case is our AC. It states that our AC squared is equals to our AB squared plus BC squared. What does that mean? If we were looking at to find the value of AC, not AC squared but AC, we were going to equate the square root of AB squared plus BC squared. As I explained earlier, if you feel like the pace it's a little bit fast, feel free, you can pause these videos and go back so that you get your content quite right and you get the explanation well explained to you at the pace that is comfortable to you. Okay, let us move. Okay, let us put this theorem of Pythagoras into action. Let's put it into real life problems. Okay, we have a triangle ABC. Now I want you guys to try and attempt this question that I have here in my screen. Now in triangle ABC, we have angle A, which is equals to theta. I'm going to talk about that theta now. We also have B, which is equals to 90 degrees, right? And we have angle C, which is equals to 37 degrees. Now in trigonometry, we don't name we name unknown angles according to Greek letters. Now we have 6 Greek letters, but for convenience sake I'm just gonna explain what this theta is. Now this theta, it's an unknown. That simply means that we don't know what is the value of that angle A. We don't know the value of this angle. We don't know this value of this angle. Now we have multiples of them. We have what we call alpha, then we have what we call beta, then we have what we call delta, then we have what we call epsilon, then we have what we call this theta. Now in this triangle, I want you to realize something. What we have AB, which is equals to 3 centimeters. 3 centimeters, and we have AC, which is equals to 5 centimeters, and we have our BC, which is equals to X in this case. Now let's try to attempt the questions that are being asked here at the bottom. The first question, it says calculate the value of X in centimeters. Now remember, we have two sides that we know and only one unknown side. What does that simply mean? It simply means that we can apply the theorem of Pythagoras. Now in terms of this triangle ABC, right, AC squared is equals to AB squared plus BC squared. But I want you to realize something there, that AC squared in most cases is our hypotenuse, right? It's our hypotenuse, which we're gonna talk a little bit about that, which is the longest side in the triangle. Okay, now from here it's a matter of substituting, right? We know that AC is 5 centimeters, and we also know that AB is equals to 3 centimeters, I mean 3 centimeters, and that BC it's equals to that X. Then now you substitute according to those values that you have there. Okay, now because we are looking for X but not X squared, right, then your answer becomes this, because you're gonna take that 3 centimeters to the other side, then your answer becomes 5 centimeters squared minus 3 centimeters squared. Then you get your square root of 16 centimeters squared. Then your answer becomes 4 centimeters squared. Now let's get into calculating the value of theta. Calculating the value of theta. Now by now we know that the sum of all angles in a triangle, this angle plus this angle plus that angle, they should equate to 180. That is why we have angle A, right, angle B plus angle C, they're all giving us 180. But we know that that angle A is equals to theta, and that angle B it's equals to 90 degrees. How do we know that is a 90 degrees? It's because of this square. This square, it indicates that that angle there is 90 degrees, and our angle C, which is 37 degrees. Then when you equate when you add that 37 plus that 90, you get 127, right? And you take that 127 to the other side, and it becomes a negative 127 degrees. Then your theta becomes 53 degrees. For you to test your understanding in terms of the theorem of Pythagoras and the sum of angles in a right angle triangle. Now I've included this slide so that you guys can pause and try to attempt those questions. Now, let's quickly look at the questions just to give you some hints. Now, I'm telling you, consider the following triangles. Determine the value of x, y, z, alpha, theta, and beta. Now, as I said earlier, all the diagrams in this video, they are not drawn to scale. That simply means that we did not use a ruler or calculate or use the protractor to measure the angles between the two lines. So now you cannot solve these questions by inspection. That simply means that you have to work it out mathematically. Okay, so it is easy. I want you to realize something. There we have that x, right? That x which is in triangle A, B, C, right? Which is pretty much easy. You'll be able to do it. So in this case, I want you to calculate the value of x, and I also want you to calculate the value of alpha. The value of alpha. Then now moving into triangle P, Q, R, I want you to determine the value of y there. The value of y, and I also want you to calculate the value of beta in this case. So then the last one, there I have triangle T, U, V. In this specific triangle, I want you to calculate the value of Z. I also want you to determine the value of theta. So you have everything that you need. Keep it in your mind, guys. Every time when you have trigonometric equations where they're asking you to calculate something, an angle, or they want you to calculate the side, as much as that you might be knowing trigonometric ratios, the first start with the theorem of Pythagoras. Then in terms of angle, start with the sum of angles, sum up to 180. But you'll see as we move along how that becomes very, 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 very easy. Okay, move on. Okay, these are the sums for, these are the answers for the previous slide questions. Everything's there, but I want you guys to work it out first. Then you can compare your answers with everything that I have in this slide. Okay, let us move. Now, I want you guys to be aware of something. Now, introduction to trigonometric ratios, and naming sides of right angle triangle. Okay, but before we start with the trigonometric ratios, I want us to start with naming sides of a right angle. Now, consider this right angle that is given below, right? Now we have triangle A, B, C, right? In this triangle A, B, C, we are given angle C, right? Angle C, which is theta in this case, right? Now, and we are given that angle B, right? That angle B is equals to 90 degrees. How do we know that? It's because we have a square sign there next to B. So now, when we're naming sides, now the side that is opposite to the 90 degrees, it has a special name. We call it a hypotenuse. Now that side is denoted by the letter H. That side is denoted by the letter H. Now that side in most cases is the longest side in the right angle triangle because it's opposite to the 90 degrees angle. The 90 degrees angle. But because we also have this angle theta. Now, the side that is opposite to that theta, right? The side that is opposite to that theta, we call it an opposite side. Now I want you guys to realize this. I'm no longer talking about that 90 degrees, but I am talking about this angle theta. I am talking about this angle theta. Now, I want you guys also to realize, just to erase so that it becomes easy, right? Now we have a side that is close to this angle theta, this side BC. This side is near that side. Then it also has a special name. Then we call that side an adjacent side. Okay, so what does that simply means? Whenever you are given a right angle triangle, the first thing that you need to do, you must be able to locate your sides. Know which side is your hypotenuse, know which side is your adjacent side in relation to your specific angle. Know which side is your opposite angle in relation to your specific angles. Because now imagine if we had another angle there, right? But I'm gonna talk about that now. So remember, the opposite side is the opposite side of this theta angle, and adjacent side is the adjacent side in relation to this theta angle. Okay, now let us look at our three trigonometric functions that we have in trigonometry quickly. Okay, the first one, we have what we call a sine. Now, a sine can be written in short as sin, but now we cannot talk about sin without talking about an angle, right? Now, because in this case we were given that angle C, it's theta, then that sine theta becomes the opposite side, this side, opposite side over the hypotenuse side, right? Then this can be further written as O over H. Then that brings us to our second trigonometric function, which is called the cosine. Now, the cosine can be written in short as cos theta, right? Cos theta, which means that we are also talking about that angle theta or that angle C. Now, the angle C or that angle theta, the cos theta can be written as adjacent, right? This adjacent side divided by that hypotenuse side. Then that can be further written as A over H, right? Then the last trigonometric functions, the last trigonometric function, we have what we call a tangent, right? A tangent. Then in short, it can be written as tan theta. That simply means that we are also talking about that angle theta that we've been talking about, that angle theta that we've been talking about, that angle theta. Now, the tangent is a little bit different, which means that it does not include the hypotenuse. Now, in this case, the tan theta, it's opposite divided by the adjacent side, which can be written as O over A. Now, grade 10s, you have to take note of this. You have to know what is sine theta in any triangle, what is cosine theta, what is tangent theta or tan theta. Now, we developed this mnemonic, right? That simplifies, or that makes it easy for you guys to remember these trigonometric functions is. Now, there we have that S there, right? That S stands for sine, right? Then we also have that C there, right? That C there stands for cos, right? Then the last T that we have there, that T stands for a tangent, right? Now, that O is for the opposite, right? That O is for the opposite, and that H is for the hypotenuse. So what does that mean? That so summarizes this whole thing. Summarizes this whole thing. That simply means that so summarizes this whole thing. Sin is equals to opposite over hypotenuse, right? That so of the SOHCAHTOA, it summarizes the trigonometric function sin. Now, in terms of that car, right? We know by now that C stands for cos, and that A is for adjacent, right? And that H is for hypotenuse. So that car summarizes this whole trigonometric function, this whole trigonometric function, right? Now let's look at the last one, the TOR, right? The TOR, that O is for the opposite, and that A is for adjacent, which summarizes this whole trigonometric function. Now, in summary, that is SOHCAHTOA. You have to know it, because every time when we'll be asking you trigonometric functions or trigonometric related questions, you have to know that by head, and will not give you in the formula sheet. You have to know it. So in summary, you have to understand what is going on in this specific slide. If you don't understand, you can always go back to get more explanation and more insight of what this slide explains. Even this one, let's try to put it into practical, or let's do it practical. Let's try to solve these specific questions that we have here in front of our slide. Now, given the right angle triangle below, find the value of x and y. In all triangle, find the value of sine alpha, cos alpha, tan alpha, and sine beta, cos beta, and tan beta. Now I want you guys to realize something there. This is how I'm gonna do things. I'm gonna do the sine, cos alpha, and tan alpha. Then you will do the last three, right? I'm just gonna show you how is it done, or how to do it first. Okay. Now in triangle ABC, ABC, we have AB equals to 10 centimeter and 17 10 centi. AB equals to 17 centimeters. Then BC, which is equals to x. And by now we know, right, that because of this 90 degrees, that simply means that our AC is our hypotenuse, right? AP is our hypotenuse, and because we have two known values, that simply means that we can calculate that value of x using the theorem of Pythagoras. Now, in this triangle ABC, AC squared is equal to AB squared plus B squared, right? Then because we are looking for x, right? Because we are looking for x, that simply means that now that x becomes the square root of 17 squared minus 10 squared, which is equals to 3 root 21, right? Then that simply means that you can just write it next to that x. But now that simply means that sine alpha, remember guys, now in this case you are talking about that angle there, right? Now what is the opposite side of that angle? The opposite side for this angle is gonna be this side. The opposite side is gonna be this side, right? And that simply means that this is the adjacent side. This side is the adjacent side, is the adjacent side. That AB becomes the adjacent side and the opposite side becomes the BC. Now if we were to write that sine alpha, that simply means that it's going to be that root 20 that 3 root 21 over 17, right, which we have there. Then the cos, we know that cos is equals to adjacent side over the hypotenuse side, which is going to be 10 over 17. That is why we have it there. Then tan alpha is going to be opposite over adjacent, which in this case is the root 21 over 10 in this case, which is that 10 centimeters. Right, now try to attempt to solve that triangle TUV and do it step by step. And my advice is this: you can pause this video and do it so that you see if you understand or not. Okay, let's move forward. Okay, there are more activities that you can do in terms of writing that sine alpha, cos theta, and tan theta in terms of x. Now I want you to realize something with this example. That simply means that I don't want you to solve for x first, right? I want you to write those trigonometric functions in terms of that x. So you don't need to solve that x, but you have to give your answer in terms of that x. So now I want you to realize something there. It's not all the trigonometric functions that you're gonna have x as part of the expression, but you don't have to simplify your answer even further. I just want to see the expression. Now I want you to picture this type of a scenario. Now, we need to determine sides using the trigonometric ratios. Now, I want you to consider a situation where only one side is given and one angle value are given to you, right? Are given to you. Now, I want you to realize something. In that type of a situation, you cannot use the theorem of Pythagoras, and you cannot use that sum of angles in a triangle that equals to 180. That simply means that you have to rely on what? Trigonometric ratios. Now let's consider this specific example that I have in this slide. Now in triangle ABC, AC is equals to 5 centimeters, AB is equals to y, BC is equals to x, and angle C is equals to 15 degrees. Then determine the values of x and y. right? As I already said, you have to remember that SOHCAHTOA because it will be easy for you guys to remember that, so that because this is a summary of all the trigonometric functions, because everywhere you go, this is what you need to know. That forms the basis of trigonometry. Now, if you're lost there, then everything that we're going to be discussing, you'll always be lost. Okay, let's look at the triangle. Right, now in that triangle APC, as we were told that AC it's equals to 5 centimeters, right? 5 centimeters, right? And we were told that AB it's equals to Y, and that BC is equals to X. Now let's try to solve there. Now I want you to realize something, right? Now if we were to determine that sine 15, right? Sine 15 degrees, right? That simply means that it was going to be Y over 5 centimeters. That simply means that we're going to have one variable, which is going to be our Y. And also, if we were to determine the cos 15, that simply means that we're going to have one variable, that X was going to be over that 5 centimeter. But now let's see. Then already we have that sine C, which is equals to AB over AC, and that cos C it's equals to BC, not AC, BC over AC, right? But by now we know that Y, that AB is equals to Y, and that AC is equals to 5 centimeters. Now I want you to realize something there. In those equations we have one variable. There in sine 15 we have Y, and there in cos 15 we have X. Now it is just a matter of cross multiplying with that 5 centimeters on both sides. Then your answer becomes Y equals to 5 centimeters multiplied by sine 15, and X equals to 5 centimeters multiplied by cos 15. Then your answer becomes this. Y becomes that value, which is equals to 1,29 centimeters, right? And your X becomes 4,3x 3 centimeters. Now I want you guys to realize, now in this type of examples, you can always try to verify your answers if they are correct or not by taking those values and plug them in terms of the theorem of Pythagoras. They should give you, if they give you that 5 centimeters, then that simply means that your values are correct. Okay, so to do, okay, now you can try to work it out, this one. Now I'm telling you, in triangle DEF, DF is equals to 7 centimeters. Now EF is equals to P, and DE is equals to R. But that angle E, not C, but angle E, right? That angle E, it's equals to 28 degrees. Now determine the values of angle F, right? Angle F, and the value of P, right? This P, and R, this R. Correct to 2 decimal place where appropriate. So it is easy with this one, right? Determining the value of that angle F, it's easy. So just try it out. Okay, let us continue. As I said, if you feel like this video is a bit fast, you can pause it and go back as much as you can at the pace that you want. And if you have more questions, you can drop down as some sort of a comment, or you can private text me on WhatsApp, then I can further explain this to you. Now, determining angles using trigonometric functions. Now consider a situation where you have 2 or more sides that are given and no angle value that is given, right? In triangle APC, AC which is equals to 5 centimeters, AP, which is equals to 4 centimeters, BC, 3 centimeters, and C, we are given that C is equals to theta. Now determine the value of theta and beta. As I already said, that SOHCAHTOA, it will always be applicable. So that simply means that you have to know it. You have to know it. Good. Now, by now we know that sine theta, right? That sine theta or that sine C is equals to 4 centimeters divided by 5 centimeters, right? Now, you'll realize that the only variable that you have is that theta. Now, for you to further continue with that sum, that simply means that you need a calculator. Now, in your calculator, you have to key in, right? You have to key in the shift button, right? The shift button. Then you have to key in that sine, then you press 4/5, right? Then in your screen you should get something like this. Something like this. Then your answer is gonna be 53.13. Now I want you to realize something now, because they have provided you with two solutions, the one for sine theta and the other one for cos theta. Now in terms of cos theta, we know that cos theta, again they have made a mistake. That's supposed to be B, right? In terms of cos theta, that BC, it must be over AC, right? But we know that BC is equals to 2 centimeters and that AC is equals to 5 centimeters. Then you do the same thing for cos. You key in shift, then you press cos 3/5. Then in your calculator, you should be able to get something like this. Something like this. Then you also gonna get that same answer, which is 53.13. Right? Now, what does that simply means? If you got your theta to be equals to this, that simply means that now you can calculate that A. But now, for interest's sake, what is that angle A? And how do you do it? Right? As I said earlier, the sum of angles in a triangle, they should equal to 180. That simply means that for you to get that value of that angle A, that simply means that you need to say 180 minus, right, minus 90 minus 53. Then you get the answer for that. That is why I said that beta there, it must be equals to that. Something for you to do, right? Something for you to do. In this specific triangle, you have that there, right? So you can also practice with this one and see, right? And see if you understood. If you don't understand, you can go back and try to listen to my previous slides explaining how to do this specific thing. Then these are the two examples that you can test your understanding with. Then if we still don't understand, you can drop me a text on my WhatsApp, or you can drop me a comment below. Right? And that SOHCAHTOA, as I said earlier, it applies everywhere. So that simply means that you have to know it. Okay, now stay tuned for my next videos. Stay tuned for my next videos, which is going to be on the application of trigonometry, right? The first thing that I'm going to talk about, I'm going to talk about special angles, trigonometric equations, trigonometric functions. So stay tuned and practice maths. You can use your textbooks for further exercises, because later in the week I'll send you a test that will sort of give you a feedback in terms of to see if you understand or you don't understand. Okay, thank you guys for joining us today in our videos. Hope to see you next time.